Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for physics for the year 2013. This is the second part of the recording where we're going to be looking at the next 25 questions. Before we continue, don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at collab.com to practice the UTME exam and modular quizzes for free. Alright, first question here on wave. A transverse wave and a longitudinal wave traveling in the same direction in a medium differ essentially in they will differ in the direction of propagation of the particles. Okay, direction of propagation of the particles of the medium. So in the case of a longitudinal wave, the direction of propagation of the particles, the direction of propagation and the direction of vibration of the particle is in the same direction. Okay, it is in the same direction. It is like to the horizontal or vertical, as the case may be. But in the case of the transverse wave, the direction of vibration of the particles is perpendicular to the direction of propagation. Okay, so the direction of propagation can be in this direction. If the direction of propagation is in this direction, then the direction of movement or vibration of the particle is going to be like this. Okay, to be perpendicular to the direction of propagation. What is the velocity of sound at 100 degrees Celsius if the velocity of sound at 0 degrees Celsius is 340 meters per second? Alright, the velocity of sound varies directly as the square root of the temperature. Okay, as the square root of the temperature in Kelvin. So you say that V varies directly as root T, the square root of the temperature. If we turn this into an equation, if this becomes equal to, that means we multiply the side of the equation by a constant K. So we have V to be equal to K root T. If we divide both sides, to get K, we divide both sides by root T. So our K will be equal to V divided by root T. Now, let's say we now have the value of V or T changing. Let's say V changes from V0 to V1 and the temperature changes from theta 0 to theta 1. Then we say that the ratio of the volume, the velocity to the temperature is the same thing, and so we say V0 over root T0 is equal to V1 over root T1. So the volume, they said the volume at 0 degrees Celsius is 340. So you can take theta T0, okay, T0 to be 0 degrees Celsius. We convert this to Kelvin by adding 273, okay, and we take this to be our V0, 340 meters per second. So the question is now to find the velocity at this temperature. So we say let this be T1. Alright, so we are now looking for V1, which will be the velocity at T1 at this temperature here. Now the temperature we are given here is 100 degrees Celsius. We will convert it to Kelvin as well by adding 273. So this becomes 373 Kelvin. Okay, we then substitute for these values in this equation. So we have the initial velocity 340 divided by root T0, which is 273, equals V1 over root 373. To get the value of V1 here, the first thing we are going to do here is this. Let us remove the square roots. These square roots, okay, let's remove them. How do you remove them? Is by squaring both sides. Okay, by squaring both sides. So squaring both sides means we will have 340 raised to power 2, which is 115,600, divided by root 273 raised to power 2, or root 273 square. That square is going to remove this root here, so we left with 273. This will then be equal to V1 square over root 373 square. The square will also remove the root here, so you have 373. Alright, we can then cross multiply. Okay, that is, we use this one here to multiply this denominator here to multiply the numerator here. So we are going to have 115,600 multiplied by 373 divided by 273. This will give us this value here, 159,744 approximately. So that is V1 square. So now get the value of V1, you take the square root of both sides. The square root of V1 square is equal to V1, and the square root of this is equal to 397.4. Approximately this is 397 meters per second. Excuse me. Next, if a sonometer has a fundamental frequency of 450 Hz, what is the frequency of the fifth overtone? Alright, so the fundamental frequency here, F naught, okay, is 450 hertz. All right. The nth overtone in a sonometer is given as n plus 1 times the fundamental frequency. So the fifth overtone is going to be 5 plus 1. Okay, that will be 6 times the fundamental frequency. So we have the fifth overtone as 6 times the fundamental frequency. That is 6 times 450 hertz, and that is 2700 or 2700 hertz. Next question. A man 1.5 meter tall is standing 3 meter in front of a pinhole camera whose distance from the hole, okay, whose distance between the hole and the screen is 0.1 meter. What is the height of the man on the screen? Alright, the magnification, we are going to use the magnification formula to solve this question here. Now there are different formulas for magnification. One is this, that magnification is equal to V, the image distance, over the object distance. The second one is, we say magnification is equal to the height of the image over the height of the object. Now in this question, they gave us the height of the object. They said the man is the object here, and is 1.5 meter tall. The object distance, that's the distance of the man from the camera. Okay, they say he's standing 3 meter in front of a pinhole camera. That is 3 meter away, okay, from a pinhole camera. So that's the object distance, the man's distance, which is 3 meter here. The image distance is going to be the difference between the pinhole of the camera and the screen of the camera, which is inside the pinhole, okay, at the back. Alright, the distance between the hole of that pinhole camera and the screen, that will be the image distance, okay, and that is given as 0.1 meter here, 0.1 meter. So the question is, what is the height of the man on the screen? So we say the height of the man, that's hi, that's what we are looking for. So what we are going to do is that we are going to equate these formulas of magnification. We say V over U is equal to height of image over height of object. So we now have V over U is the height of the image distance, which is 0.1 over 3, is equal to height of the image, which is what we are looking for, over the height of the object, which is 1.5 meter. We will then cross multiply. Okay, we will cross multiply. The denominator will multiply the numerator here, and this one multiply this here. So when you cross multiply, 1 times 1.5, okay, is going to be, 0.1 times 1.5 is going to be 0.15. Alright, and 3 times this is going to be H3hi. Then we divide both sides by 3. So our hi is going to become 0.15 divided by 3, which will be 0.05. Okay, that will be 0.05 meter. A ray of light passing through the center of curvature of a concave mirror is reflected by the mirror arch. Now the ray of light, okay, passing through the center of curvature of the concave mirror is going to return back through that same line. So the angle of reflection, the angle between the reflected ray and the refracted ray there, is going to be 0 degrees, since it's the same line. Okay, the same line, or let's say since both lines are from the diagram above, calculate the incident angle I. Alright, so since the light is traveling from the glass, okay, into the water, then we say that the refractive index of the light is equal to the refractive index of the water over the refractive index of the glass, which will be equal to sine of the angle of incidence, okay, over the sine of the angle of refraction. So the angle of refraction of the water, the refractive index of the water is given as 1.3, so you have 1.33 divided by that of the glass is 1.52. This is equal to sine I, the angle of incidence, over the angle of sine the angle of refraction, which here is 90 degree. Okay, because this is the refracted area. So the angle between the normal and the refracted area is 90 degree. Sine 90 degrees is equal to 1, so you just have sine I here, and this divided by 1.5 will give us 0.875. Okay, then to get the value of I, we take arc sine of 0.875, the inverse trig. So this will be 61.4 degree, which is approximately 61 degree. Total internal reflection will not occur when light travels from. So there are two conditions for total internal reflection to occur, two necessary conditions. One of it is that the light must be traveling from a denser medium to a less dense medium. Okay, from a denser medium to a less dense medium. The second one is that the angle of incidence must be greater than the critical angle. Now the one that is more related to what we are discussing here is the media, okay, between which the light is moving. So the condition, like I stated, is that it must be traveling from a denser to a less dense medium, and generally solids are denser than liquids and liquids are denser than gases. Now if it is going from water to air, it's from a denser to a less dense, from a liquid to to a gas, to a mixture of gas. But here from water to into glass is no, because water is a liquid, glass is a solid, and liquids are less dense than solid. So this is going from a less dense to a denser. So this should be our answer. So total internal reflection should not occur in this case. Let's continue with the other option. From glass to air is still from a denser to a less dense, from a solid to a mixture of gas. And from glass into water is still from a denser to a less dense, that's from a solid to next. What does the diagram above represent? This diagram represents a telescope in abnormal use. Okay, when a telescope is in abnormal use, the final image will be formed at the near point, as we have in this diagram. If it is a normal use, the final image will be at infinity. These two lines, they will not meet like this. Okay, it will just be, they will just be parallel to each other continuously. All right, but when it is in abnormal use, that's when the image, they are formed at the near point, as is the case here. If the linear magnification of the objective and the eyepiece convex lenses of the compound microscope are 4 and 7 respectively, calculate the angular magnification of the microscope. The angular magnification of the microscope is going to be equal to the product of the linear magnification of the objective and the eyepiece lens. Okay, so that is 4 times 7, so we have 28 here. The angle of deviation of light of various color passing through a triangular prism increases in the order. So the most deviated is red, followed by orange, then green, and then blue. Okay, then I have we have red, orange, yellow, green. Okay, then blue, indigo, and violet. Alright, so the increasing order is from red to orange to yellow to green to blue to indigo to violet. So this follows the order here: red, green, blue. But if you look at this one, the order here is, violet is the last here. Violet has the greatest angle of deviation, but here is not in the middle of, like saying blue is even greater than one of that. So all of this is wrong. The sequence is wrong in all of this, except for this one here. Calculate the force acting on an electron of charge 1.5 times 10 raised to the power minus 19 coulombs placed in an electric field of intensity 10 raised to the power 5 volts per meter. Alright, the electric force acting on that electron is given as the electric field intensity E times the charge Q. The electric field intensity is 10 raised to the power 5. Multiply that by the charge Q, which is 1.5 times 10 raised to the power minus 19. We are going to use the law of indices on this 10 raised to the power 5 times 10 raised to the power minus 19. 10 raised to the power x times 10 raised to the power y is equal to 10 raised to the power x plus y. So 10 raised to the power 5 times 10 raised to the power minus 19 will be 10 raised to the power 5 plus minus 19. Plus minus 19 is plus times minus 19, and that will be minus. So you have 5 minus 19, which is equal to minus 14. So you have this to be 1.5 times 10 raised to the power minus 14 Newton. Next question. Capacitors are used in the induction coil they are used in induction coils to prevent electric spark. Okay, to prevent electric sparks. A cell of EMF 1.5 volts is connected in series with a 1 ohm resistor, and a current of 0.3 ampere flows through the resistor. The question is, find the internal resistance of the cell. Alright, the EMF is given as I, the current, in bracket, the external resistance R plus the internal resistance small r here. The capital R here is the external resistance, the small r is the internal resistance, and this is what we are looking for, this internal resistance here. From the question, they gave us the EMF as 1.5. The current is 0.3 ampere. Okay, the external resistance is 1 ohm. Okay, so we have 0.3 in bracket 1 plus r. We are going to divide both sides by 0.3 to remove this 0.3 here. So we are going to have 1.5 divided by 0.3. That will give us 5 is equal to 1 plus R. To get the value of R here, we will bring this 1 to this side. So this becomes 5 minus 1 is equal to R. So R is equal to 4 ohms. We have our website at Collab.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at Collab.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next question: which of the following obeys Ohm's law? Metals generally they are ohmic conductors, okay, meaning they obey Ohm's law. The other ones here, they are non-ohmic conductors. In fact, glass is not even a conductor, so that one is even out. Glass is an insulator. So the electrolyte and the diode, and you also have like transistors, they are non-ohmic conductors. They do not obey Ohm's law. But metals generally are ohmic conductors. A house has 10, 40 watts and 500 watts bulb. How much will it cost the owner of the house to keep them lit for 10 hours if the cost of a unit is 5 naira? So here we have to calculate the total energy, electrical energy that is used by the bulbs here. Now that house has 10, 40 watts, okay, so the total energy that those ones will use will be 10 times 40, that those 10 bulbs will use, okay, it will be 10 times 40, that's 400. Then 5 of 100 watts bulb, that is 5 bulbs each with a power rating of 100 watts. So the energy they will consume will be 5 times 100, so we have 500. So we have 400 from here and 500 from here. 400 plus 500, that is 900 watts. So convert this to kilowatts, we are going to divide by 100 and by 1000. Okay, 900 divided by 1000 will give us 0.9 kilowatts. So the time here, okay, the time that is for which these appliances were used, okay, is 10 hours. Okay, they were kept lit for 10 hours. The quantity of electricity that is now used here, okay, or electrical energy consumed there, is going to be equal to the electrical power, the total power consumed times the time. So that will be 0.9 times time here, which is 10. So you have 9 kilowatts hour. Now they said 1 unit of electricity is 5 naira. That 1 unit is 1 kilowatt hour. Okay, 1 kilowatt hour. So we have 1 kilowatt hour to be 5 naira. 9 kilowatt hour will then be 9 times the cost of 1 kilowatt hour, which is 5 naira. That will be 45 naira. Next, an electrical device is rated 200 watts, 250 volts. Calculate the maximum power it can take. Alright, the power of the device P is given as IV, okay, where I is the current and V is the voltage. Now from the question already, from the rating that we are given here, this is the power of the electric device. Okay, how do we know that it is power? From this unit here, because the unit here is watts, which is the unit for power. So the power is 2000 watts, while the voltage is 250 volts. Okay, 250 volts. So you are going to have the power 2000 watts. The voltage is, or the potential difference is 250 volts. So we say P is equal to IV. Now what we are looking for is a current, right? The maximum current that it can take. So we make I the subject of the formula here by dividing both sides by V. So we divide both sides by V, we have I to be equal to P over V. So the power, which is 2000, divided by the voltage, which is 250, and this will give us 8 ampere. Next, when a charge moves through an electric circuit in the direction of an electric force, that charge, because it is moving towards a force, okay, that force is going to impede its motion. Okay, it will impede its motion, so it will lose kinetic energy. It will be losing kinetic energy gradually, meaning that force, okay, will be bringing that charge to stop. Okay, so in that case, the kinetic energy of that body, that's the energy with which it is moving, is going to be reducing. It will be losing it, while it will be gaining kinetic energy. To convert a galvanometer to voltmeter, In converting a galvanometer to voltmeter, you connect a high resistance, which is known as a multiplier. A high resistance is connected to the galvanometer in series. That's when you are converting from galvanometer to voltmeter. You connect a multiplier, a high resistance in series to the galvanometer. But if you want to convert from galvanometer to ammeter, you connect a low resistance known as a shunt, okay, to that galvanometer in parallel, okay, in parallel. Induced EMFs are best explained using Faraday's law of electromagnetic induction, which states that whenever a conductor is placed in a varying magnetic field, an electromotive force is going to be induced. Okay, so induced EMF can be explained using Faraday's law. If a current 2.5 ampere flows through an electrolyte for 3 hours and 1.2 grams of the substance is deposited, what is the mass of the substance that will be deposited if a current of 4 ampere flows through it for 4.8 hours? Alright, from Faraday's law of electrolysis, we have M to be equal to ZQ, where this M is the mass of the substance and this Q is the quantity of electricity. So from here, if you want to make Z the subject of the formula, we just divide both sides by Q. So we are going to have Z to be equal to M over Q, where this Q is equal to IT, current times time. Now, so if you now have varying mass of a body, let's say you have mass M1 and mass M2, current I1 time like that, okay, then we say that the ratio of the mass to the product of the current and the time is constant. So you are going to have M1 over I1 T1 to be equal to M2 over I2 T2. Now, if a current of, from the question, if a current of 2.5 ampere flows through an electrolyte for 3 hours and 1.8 gram of the substance is deposited, we are going to take this as the original current that flew through the electrolyte for this time, okay, 3 hours, and this mass is deposited. So you take this as I1, this as T1, and this as M1. Then the next values that are given here, we take this as I2, we take this as T2. So we're now looking for M2. Okay, so we substitute these values into the equation that I have here. So you have 1.8 over 2.5, okay, in bracket 3 is equal to M2 over 4 times 4.8. okay, now we are going to cross multiply here. Alright, we will be cross multiplying. So if you cross multiply, we are going to have 1.8 times 4 times 4.8 over 2.5 times 3, which is 7.5. Now this times 1.8 will give us 34.56. Divide this by 7.5 and you get 4.608. Approximately this is 4.6 gram. Okay, you can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at collab.com, or you could also check it out in the video description below. Calculate the energy of the third level of an atom if the ground state energy is minus 24 electron volts. Okay, the energy at the nth level is given as En, that is energy at that nth level, is equal to E naught, the energy at ground state, over N square. Now the energy at ground state here, the ground state energy here is minus 24 electron volts. I will ask to find the energy at the third level, that is N here is the third, the nth third, the nth level is the third level here. So we substitute for that here, the ground state energy, which is minus 24 over N here is 3 raised to power 2, so we have 9. Minus 24 divided by 9 will be minus 2.67 electron volts. In photoemission, the number of photoelectrons ejected, that is liberated, per second depends on the frequency of the beam, that is the frequency of the light ray. That is what we call photoelectricity is I want to put this in a layman's language, is the ejection or the liberation of photoelectrons when a light ray falls on a clean metallic surface. When light rays or electromagnetic radiation falls on a clean metallic surface, okay, that emission, that phenomenon, okay, that phenomenon is what we call photoelectricity. Okay, now the number of those photoelectrons that will be liberated, okay, or that will be liberated or ejected per second depends on the frequency of that light ray that is reaching the surface of that clean metal. Next, the particulate nature or the particle nature of light is demonstrated by the diffraction of light. Okay, the properties of waves such as diffraction, they show the particulate nature of light, that light consists of, okay, or may be regarded as a particle. Next, on photoelectricity, the energy of a photon having a wavelength of 10 raised to power minus 10 meter is, we have the Planck's constant and the speed of light. Okay, the photon energy, all right, or the energy of the photon is given as E, which is equal to hf, where this f here is the frequency of incident radiation and h is the Planck's constant, and this frequency is given as the speed over wavelength. The speed, in this case we are dealing with the photon, a photon here, so this will be the speed of that photon, okay, or light, over the wavelength. Okay, now from here we already have the Planck's constant h as 6.63 times 10 raised to power minus 34. We multiply this by the speed of light, which is 3.0 times 10 raised to power 8, divided by the wavelength, which is 10 raised to power minus 10. Then for this we are going to do 6.63 times 10. Okay, so this is going to be 19.89. Then we now say times, so now we lose the law of indices on all of this 10 that I have here. So this 10 raised to power minus 34 times 10 raised to power 8 will become 10 raised to power minus 34 plus 8, then minus, because this is divided, minus 10. Now minus will become plus, that is minus times minus will become plus. So we're now going to have minus 34 plus 8 plus 10. Okay, so this will be 19.89 times 10 raised to power minus 34 plus 8 plus 10 is going to be equal to minus 16. Okay, minus 16. Then we will borrow a 10 from here, or remove a 10 from here. Removing a 10 from here means to divide this by 10. So if we divide this by 10, this will become 10. This will become 1.989. We now add that 10. Okay, we are going to add that 10 here. Okay, we'll add that 10 that we have borrowed or that we removed from here, that we used to divide this. We'll add it to this one. Okay, so that means that 10 is 10 raised to power 1. Okay, 10 is 10 raised to power 1. So what it means, what I mean by adding into this one means adding that raised to that power of 1 to the power that I have here. So this will be minus 16 plus 1, and that will be minus 15. Okay, minus 15. 1.989 is approximately 2.0. So we say this is 2.0 times 10 raised to power minus 15. Final question here. The bond between silicon and germanium is a covalent bond. Okay, silicon and germanium, they each have 4 valence electrons. Okay, they have 4 valence electrons, that is 4 electrons in their outermost shell, and as such they form a covalent bond where they pair, okay, they pair or share electrons. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Collab. Okay, like and share our content, and visit our website at collab.com to practice UTME exam and modular quizzes for free. Thank you.